Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and today, as per my review of the work that I'm doing every day, I've come across one of these Corbett Maths 5-a-day starters. A major issue on this one, not a big deal, just take a couple of minutes to go through. A reminder, of course, my LE, UF, GE, you're expected to be doing one of these every single day. So let's begin. First of all, question 1. Make x the subject of t equals x 3x squared minus y. That means I just want to make this into x equals something. So let's begin. Going to add y to both sides, cancels that one out. T plus y equals 3x squared. Next step, divide both sides by 3 to get x squared on its own. I'm going to write the solution to that bit up here. T plus y over 3 equals, because the 3 in front of the x squared, and that divided by 3 cancels out, just x squared. And then square root both sides. So it's t plus y over 3, all square rooted, equals x. Magic. That's it. X has been made the subject. It has been isolated, put on its own. So that's that. Next part, circle theorem. Because it's a circle with a four-sided shape, quadrilateral, a corner touching each point of the circumference here of the circle, making this quadrilateral what we call a cyclic quadrilateral. What we need to remember about cyclic quadrilaterals is the opposite angles in cyclic quadrilaterals add up to 180. So angle ABC here is going to be the difference between 180 and 95, which is 85 degrees. And the angle DAB here is going to be the difference between 180 and 62 degrees, which is 118. We're racing through this. This isn't taking much time at all. The last little section is where one of my pupils had a bit of an issue. So look, the surface area of this cuboid is 270 centimeters squared. And from that information and from these dimensions we're given on this cuboid, we need to show that x squared plus 4x minus 45 equals 0. Yeah, it seems a bit random to be asking for that given this information, but it is possible. What we need to remember, of course, is that there are 6 2D shapes coming together to make the faces of this cuboid. This is a square, x by x, and opposite side is also a square, which is also x by x. There's a rectangle on the top, that's x plus 6 by x, and there's also a rectangle on the bottom, that's also x plus 6 by x. And then this side on the top, this front-facing rectangle, excuse me, is x plus 6 by x, and then the one at the back is x plus 6 by x. So let's think about that. There's 2 squares that are area x squared each, and there are 4 rectangles of x by x plus 6 area each. So let's write that down algebraically. 2x squared, right, because there's 2x by x squared, plus 4 lots of x times x plus 6. Whew. That equals 270. I hope that makes sense. So this x squared represents the area of one of these squares. This x times x plus 6 represents the area of one of these rectangles. And there are 4 of those rectangles and there are 2 of those squares. Hope that makes sense. So let's simplify this. 2x plus 4 lots of x times x, x squared, x times 6, 6x equals 270. Next line of work is therefore going to be plus 4x squared. 4 times x squared is 4x squared, and 4 times 6x is 24x equals 270. Okay, bit tricky this, because this is a single bracket within another single bracket, but you work from the inside of this outwards. I hope that makes sense. Let's collect some like terms. 2x squared plus 4x squared makes 6x squared. and then plus 24x equals 270. You know, I'm going to be brave. I'm going to do 2 steps at once here. If I take away 270 from both sides here, that cancels out and leaves me with equals 0 on the right hand side of the equals sign. But I have a minus 270 on the left hand side of the equals sign. So 6x squared plus 24x minus 270 equals 0. Not quite x squared plus 4x minus 45, is it? Let's divide every term by 6. Simplify every single term. 6x squared divided by 6 is x squared. 24x divided by 6 is 4x. And 270 divided by 6, you can get out your calculator and do that for yourself if you want, but actually the clue's in the question. It's minus 45 equals 0. So at that point, I've answered this first question. I've used a little bit more space than I've been allocated, but that doesn't matter as long as I get the answer. And the last little bit is to find x. Basically, solve the quadratic. So let's do that. You know what, I reckon this factorizes. What's 2 numbers that add together to positive 4 and multiply together to make negative 45? Well, that's plus 9 and minus 5, isn't it? Yeah, 9 adds negative 5 makes positive 4, and 9 times negative 5 is negative 45. There you go. So the solutions for this are either x equals negative 9 or positive 5. Okay, so that's a satisfactory mathematical conclusion, but listen, we're dealing with lengths here. Would it make sense for this square to be a minus 9 by minus 9 square? Of course it wouldn't. Negative lengths don't exist, so the value of x has to be 5. It's got to be the positive solution in this particular case. I hope that makes sense. That's another Corbett 5 in 5. It's taken me 7 minutes because I'm slow, but I'll bet you can do this in 5. Have a wonderful day. Keep working hard, and for goodness sake, upload your work to Teams. I will talk to you very soon.